Welcome. In this video, we are talking about WireShark and kind of what it is and how to use it. So I'm going to go ahead and open up WireShark. And I'm going to be using my Evidence 01 PCAP for this overview. So first of all, WireShark is a packet capture analysis tool. It is used to capture data on a network, and it will save it as a PCAP or packet capture file. We can take that PCAP and we can dissect it. We can draw data out of it. We can see session communications, so between a client and a server, or data that was sent that was unprotected. We also have the ability to listen for secured information, anything being sent over like an SSL encrypted connection. We have the ability to capture the encryption and then try to decode or break it. So first things first, we have Packet Tracer open. We have a PCAP file loaded. Top area, this area up here where it says file, edit, and so forth, that's the menu. Next is our shortcuts. If you mouse over them, it'll give you a nice little preview. Because we are dealing with a PCAP file, we aren't going to be capturing new data. So we don't need to worry about the capture, because that's the start capture, that's the stop capture. If we wanted to capture new data, that's how we would be doing it. Next, this section right here, this little display filter area, this is our capture filter area. And we also have additional options. You can mouse down if we have previous saved commands. We also have the plus sign that gives us additional options, because we have different ways of filtering things if we want to. Right now, we're not going to be worrying about that. We're going to be focusing on the other areas. I'm going to cancel that. The next window is going to be the packet list pane. That's going to be this area right here. It's important to note we can filter off of different columns. By default, it's filtered off of the number or the no column. No is going to be the number. That's the frame number, and so forth. We have the length of time. And so we can do some type of time analysis. So you'll see this is the beginning, and from here it goes to, I don't even know what millisecond, microsecond version that is, but you'll notice the time builds on itself. So we can actually build a timeline based off of our time. We have our source addressing, our destination addressing, our protocols, our length, and our different types of specific information. If we are looking for HTTP GET information, we can be filtering off of protocols and information. We may filter out of protocol to HTTP, and we may filter info into GET requests. So it just kind of depends on what we're trying to accomplish. So the next pane is going to be the packet detail pane. That's going to be down here. This is going to give us our details on our frame. It will let us drill down on our individual frames. So the top part will be frame. Second part should be an Ethernet frame as well. That's going to be our destination and source addressing, our MAC addresses. It should give us a type of layer 3 detail. Here our layer 3 is going to be IPv4. So the next section will be the packet portion. So here's the packet header. So you'll see all of the different information that would be in a packet header. We will end it with our source and destination. From there, we have our segment header, our layer 4 header. Here, we're using UDP, User Datagram Protocol. Destination and source ports being listed as well. So here we have our layer 2, layer 3, and layer 4 pieces of information. And in each one of these, as you navigate through them, you'll see that our bottom pane, our dissect pane, will change based off of whatever frame, packet, or segment we are looking at. You'll see down here we have specific information, our PCAP, our packets we're looking at. If we are clicking on anything, we may get more specific details on what we are looking at. Here I clicked on IPv4, source and destination. You'll notice at the bottom it does the IPv4, IP, and it gives us our length. If I go to our user datagram protocol, UDP, you'll see that it's showing 8 bytes. So it gives us some detail. So that's a rough overview of our navigation of our program. So one of the important parts that we have to look at is how do we filter data? And that's where the display filter portion comes into play. Because looking at mass amounts of data doesn't do us any good. We need a way to be able to block or filter out certain types of things. So maybe I want to look at TCP. Well, you'll notice as I was typing, the color changes, TCP. TCP shows a green bar. TC shows a red bar. So we have 3 colors, red, green, and yellow. Yellow is a rare sight in WireShark, but it essentially means ambiguous results. There are times when you are filtering and WireShark may think that your syntax you're using may not yield the results that you want, so it will actually display a yellow bar. And I sadly cannot think of an example because I've only seen them a few times. So I'm going to go ahead and filter off a TCP. As you start typing, you will get lists of commands. So these are all the commands that start with TCP. I can do just straight TCP, and it will show me all the TCP protocols that are in this packet. So it shows TCP, SSH, SSL, TLS v1, because those are all TCP-based packets. Maybe you want to filter off IP address. So you can type IP dot address. I want it to equal. I have to do a double equal sign to get it to equal something. I want to look at the source IP address 192.168.1.158. And my num was not on. 168.1.158. So why doesn't it work? Because as I was typing, it's not just add, it's add R. So you have to be careful with your filtering because the filtering is not really forgiving. Well, here I didn't specify source or destination, I just put IP add. So it listed anything that was communicating with or from that address. So while this listed that, I actually want to look at just this as the source. So I can do IP, maybe look through my lists, look at the options, source, SRC, and I can set that equal to my address that I want to search for. If you leave extra spaces, it should also work. That means I'm filtering off of this address as my source. When you're getting into Packet Tracer, learning the filters becomes one of the harder parts as you get into it. But I'm going to be doing several other videos covering different types of filtering so we can figure out how to pull data out of WireShark. This video is just more of a quick overview of how WireShark functions and some basic functionality. So I want to show you a few more things. We earlier in a previous video talked about sessions. Here we have a TCP connection. We can actually right click and do follow TCP stream. That's looking at the different sessions. We can look at the different sessions or the different streams. So here's stream 1, this is the first communication. Here's the second communication. Here's the third communication. And again, as we start reading it, notice the color code. Red is one response. It's sent, received, sent, received, sent, and received. So again, it does vary. And as you go through and you click on them, we can see what packets are being pulled out. So here, this is packet 25, or sorry, frame number 25. This is frame number 29. This is frame 92. So stream 2 is made up of all of these different frames, and this is a back and forth communication. This isn't just sent or received. This is sent, received until the communication was complete. So that's stream 2. Here's stream 3. And again, as we start looking through it, we can start decoding some information, or we may see just gibberish. It just kind of depends. Here, I don't see anything that's distinctual, so it's not really overly relevant at this time. Here I see back and forth. And again, I don't see anything of substance as I look through it, so I'm okay. DF, PK. Oh, well, see, that's one of the things that as we start looking through it, this PK means something. As we look at this long string of blue, PK just happens to be a signifier of a file being transferred. In a previous video, we were looking at Network Miner and how to pull a file out. Here, we're looking at the raw data of that file transfer. Makes it a little bit harder if we are looking at the file in Packet Tracer. So file extraction is not always the best in Packet Tracer. Hence, use more than one tool to complete these tasks. Don't just rely on one. You can take this, save the PK file, and it actually will save as a correct file. But you have to be very specific on what you actually capture, and that's outside the scope of this video. So let's go on to stream 5. Stream 5, we can see that there was a file being transferred. Here we see the PK. We now start seeing identifiers identifying like file name. Here's the PK again. So if we go through all of this, this would actually be the data file. We see OFT2, we see file transfer. Those are indicators to us going, oh, hey, this was probably a data file. Again, this is not always the best tool for data extraction. If you have the ability to use other tools, open the same PCAP up in other tools that verify. Here we have the next stream, stream 6. We see that it is some form of web proxy. They're communicating. This is referring to this type of website. As I go through, I can start seeing that, okay, this is probably, here's a cookie. Here's the user agent. This is the browser that was used to access it. This was a GET request. So we can start decoding pieces of information from this. This was a website that they used to access, I'm assuming, some form of email or website or web-based email. Going on to the next session. I don't like when it does that. Session 7. Alright, that was the last session. So those are our follows, so we can follow our streams. And again, as we were following it, it actually was modifying our display filter. We have 3 other major tabs of review. We have our analyze. We have different ways to do our display filters. Sometimes WireShark will help you and give you some of the display filters, some basic ones. You can do display filters using regular expression. That's outside the scope of this video. We have, again, our capture to start and stop. View is not going to be more specific to our PCAP. It's going to be more for WireShark and how it's set up. Statistics is one of the big ones that we will be using in this class. So with statistics, we can look at things like resolved addresses. It will actually show our MAC addresses and what they are. Our protocol hierarchy. It will give us a breakdown. So 100% of this were frames, 100% of them are Ethernet frames. Most of the data was IPv4 packets. Of that, we had 19.6 as UDP protocols, and we had the remaining 72.1% being TCP. So here are our 2 major, layer 2, layer 3, these are our layer 4 protocols. This makes up our group of our percentage for our IPv4, and it shows how much data was sent in each type of protocol. So here, how much of that traffic was SSDP, how much of this was NTP, how much of this was NetBIOS, or NetBIOS name versus NetBIOS datagram, versus how much of this was SMB, how much of this was TCP, TLS, SSH, how much of this was HTTP. So we can start getting a breakdown of how much data was sent, how much of the overall data was what type of data, how many packets were sent in each one, the percentage of packets that were sent in each one, and so forth. We can also look at size, speed, the end packets, end bytes, and so forth. So that gives us our protocol hierarchy. Statistics, we have our conversations. Again, this is going to be filtered off of different ways. Here's our Ethernet. This is going to be between source and destination, each source and each destination. So here, the first 2 is going to be between host A, that one MAC address, and a specific other device, and the different broadcasts. So every time there is a conversation, whether it's a broadcast, unicast, or multicast, it's going to be documented here. And again, it's going to list how many packets, how many bytes were sent, how many were sent from A to B, how many were sent back from B to A, both in packets and bytes. So we can see how much data and how many packets were being sent and received. You can filter off of frames, our IPs, and our segments. Again, layer 2, layer 3, layer 4. And sometimes you can do name resolution. So this will change the MAC address into a readable name. So these are all VMware adapters. Here's an HP adapter, here's a Dell adapter. If you go to any of the other layers, layer 3 or layer 4, name resolution is not there. The other layers do the exact same thing, filtering based off of conversation from source to destination, each source and every destination. So here we have from this source to that, and it breaks down packets, bytes, and so forth. Here we have the same two addresses as the source, but different destination addresses. And again, each conversation is broken down, both in packets and bytes for size. And you can see that in our layer 4 protocols, both TCP and UDP as well. That's conversations. We have endpoints that actually break down the different endpoints. Name resolution will show you their names. So we actually have these amount of devices, and we can see who's sending and receiving the most data. So realistically, these two are probably the primary devices on the network. And we, again, IPv4, layer 3, and layer 4 data. And it's broken down into packets and bytes, both sent and received. So we can see who's sending the most data, who's receiving the data, and so forth. We also have packet length, so we can see how many packets were large, how many packets were small, and vice versa. So we can see the amount of packets. We have a total packet count of 240, while 107 of them were between 40 and 79 bytes, where 64 of them were between 80 and 159 bytes, and so forth. We can also have our graphs. This is going to be listing errors. We can filter this off of different options, all depending on what we need. And we can modify our time based off of 10 seconds. 10 minutes, it shouldn't yield anything. But there are going to be instances where we're going to need our charts to actually be able to list our data. So this is a brief overview of Packet Tracer, the different panels, and the key areas and statistics, and being able to follow data that we're going to be using throughout this course. Also, again, the apply filter is going to be separate videos as we walk through the more complex portions of applying different filters. If you have any questions, please reach out. Thank you.